Hello, and welcome back to another episode of
Wow! How'd you code that?
Today, we're solving the HackerRank challenge, max-min. The problem statement reads: you will be given a list of integers as an integer array, ARR, and a single integer, k. You must create an array of length, k, from the elements in the integer array, such that unfairness is minimized. We'll call that array suba-r-r. Unfairness of an array is calculated as the maximum value, or the largest integer in the subarray, subtracted by the minimum value, or the smallest integer in the subarray.
As an example, consider the array 1, 4, 7, and 2, and k equals 2. Picking the values 4 and 7, with the maximum value being 7, and the minimum value being 4, unfairness equals 3. Testing for all pairs, the solution 1 and 2 provides the minimum unfairness.
In the following example, you are given an array containing 7 integers, and k equals 3. Taking all permutations of subarrays in consideration, the subarray containing the values 10, 20, and 30 produces a minimum unfairness of 20.
My first attempt at solving this challenge was an epic fail. Although my code worked great for the first 6 test cases, it was terminated due to timeouts on test cases 7 through 13. Looking at test case 7, with over 100,000 elements in the array and a subarray limit of 10,000, it's quite clear why my code failed. So, after rethinking the problem and realizing that by sorting the original array, I could eliminate the process of evaluating each permutation of the subarrays, subtracting the max and min values, storing those values in a list, and determining the minimum value in that list. And the optimized solution looks like this. After sorting the incoming array, I set a primitive integer named result to the largest value in the array, denoted by the last element in the sorted array. The result variable will contain the minimum unfairness of a k-length subarray in the incoming array. Next, I define a for loop to traverse each element in the array, up to the last element subtracted by the value of k. Next, for each element in the array, I determine if the last element at the position of I, plus k minus 1, subtracted by this element, is less than the value of result. If it is, I reset the value of result to the value of the last element at the position of I, plus k minus 1, subtracted by this element. Once all of the elements have been evaluated, the value of result, the minimum unfairness of a k-length subarray in the incoming array, is returned to the caller.
Awesome job! Now, if you enjoyed this challenge, be sure to like this video, share it with your friends, and subscribe to this channel.
Thank you for watching.
And we'll see you in the next episode of
Wow! How'd you code that?